All right, that should be good now. So let's go. Okay, all right, good. So, um, just to reiterate what I said, and I like to reiterate for emphasis, not that I don't think you understand, but that I like to say it over and over again, so it's drilled into you. So I think of a general purpose computer as a tool that has several functions. Yes, it is programmable. It is also electronic. And of course, it can accept input. It can process that input. It is able to store it, and then it will also process it. We'll talk about that again. So that what I showed you earlier was an actual more abstract view. But more specifically, we want to look at the central processing unit. Now, the central processing unit is what we refer to as the brain of the computer. Just like you and I have a brain, it has a brain, which means that without anything sensible, and just a thing that without the CPU, your computer is not able to fetch instruction, decode instruction, or execute instruction. Because we can't look at the CPU and look at those little and see these parts with the naked eye, then we have to use an abstract view to explain the CPU, its purpose, and explain it in depth. So think of this as your CPU or your one of the main part that is in your CPU. It is your control unit. Now think of this guy as the errand guy. This is the one that goes and fetches instructions. Fetch means it goes to the when the keyboard sends instruction to the memory. Yes, this takes the data from the memory, right? And when it goes in, it interprets what needs to be done. That is what decode means. So it checks what needs to be done. And finally, it executes what needs to be done. Now, there's also what is called the arithmetic logic unit, something you're pretty familiar with already. You'll have heard that already. Now, this is responsible for all your arithmetic logic operations. And we could take it a step further. Whenever you write a program or whenever the computer needs to make a logical operation, such as a decision based on a condition, you will need your arithmetic logic unit in order to execute that. Now, there are other parts that are in the CPU that are above your CXE level. But I would love to mention them since you are, we're not just teaching you for the curriculum, but I'm teaching you to become young experts in this particular field. There's what we call registers, and there are about 5 main registers that are there, and they are needed because this is how the CU fetches instruction from memory, stores them temporarily, and then return to memory. So let's look at the function of the CPU again. The CPU fetches the instruction. That's what this arrow means. So it fetches instruction from memory. So for anything to be processed, it must first be a resident of the memory. All right. In the very same way that in order for you to eat food at your mom's house, you need to be a resident of your mom's house. So everything that is needed to be processed need to first be held in memory, need to be a resident. Now, nothing stays in the central processing unit forever. As soon as that instruction is fetched, it is decoded, it is executed, then it is returned back to memory. That's what this means. So let's take a look here. Here's input coming in for your input device. This is fetched, this is decoded, executed. It is either sent to memory and it could also be sent to the output device. So for example, if you're typing up a letter, the instruction comes through the keyboard, it is executed, it is temporarily held in memory, but it is also pushed out to the output device. All of this happens so quickly, right? So this is how your CPU functions. So again, your CPU is the brain of the computer. Yes, it is what is needed to get the computer to fetch, execute instruction. I'll go a step further to establish that this is also called a processor, and it's a processor for a reason. Because when you think about your microwave, which has in itself a little computer we call an embedded system, it is an embedded system because it performs a specific task or a limited amount of task. If you think about the microwave, a microwave can only what? Heat up your food. It has limited functionality, right? But it has to have a processor in there that when you press the button, which is your input device on your microwave, this instruction is processed, carried out, executed, and done based on what you think. I'm going to pause and ask you to type in the chat what might be some other types of embedded system in your home. Microwave is one. Tell me another device that has to have a processor. It needs a brain because you have to send some input that has to be processed and then executed. Tell me some other embedded system. They are not general of things. But can you tell me some others that might be in your home? Some other embedded system? Type in the chat. Television, very good. Television is, yes, it inputs. Then the brain decode and execute. That's a very good one. I am seeing another one, washing machine. A speaker would not necessarily be one because a speaker by itself is just an output device. All right, so a speaker by itself, or it might mean that I need to look at what kind of speaker you're talking about. Maybe you're talking about a component set, one of those old time ones. Well, probably, but not that one. Let's look. Definitely, a refrigerator has a brain in there. That's why you're able to give some input. This input can be processed and executed. That is how the computer is able to do what you want it to do. But they are not they're not general purpose computer. I want you to now type in the chat, why is it that the thing you name, the fridge or the washing machine and the microwave, why is it not considered general purpose? Write some points in there and let me know. Why is it not general purpose? So it is a computer, but just not a general purpose computer. Go ahead and type in the chat for me. All right, I'm seeing from, let me go back there. Nice. Um, yes. So expand that word one or limited functionality, Katrina. And the reason for that is we could argue that the washing machine does more than just one thing. Wash, it also that word limited, one or limited. So that tells the examiner, whoever we're speaking to, that we are clear as to what we are saying. We could also expand it by saying that the washing machine will always be a washing machine. So it cannot be expanded. It it cannot be reprogrammed. It is a washing machine functionality as we would do with a laptop or a desktop. So that makes it limited, which means it is sorry about the, I don't know what's happening. We had a storm last night and consequently a little bit shaky. So please do pardon with me, but we're going to get going and see what I have it here for you. The general purpose computer system is designed to perform a wide variety of tasks. Remember, I said I think of it as a tool that can be used for several different purposes. So if you're taking notes, that's a good time for you to snap, screenshot, whatever else you do. It is not limited to one. Run many types of software applications. So if you need Excel, you can download Excel. If you need some form of other app, you can. So that's what that means. Oh. All right, we're gonna try again. If it gets worse than this, then I'll just reteach this if I need to. All right, I really apologize for this. We had a storm. Storm is still outside, so we're losing the internet going in and out. So sorry about that. I said let's go quickly into the main functions of the general purpose computer. These are the core ones. It needs to be able to input. Input means to enter data into the computer. This is done by a keyboard, a mouse, a scanner, a joystick. It might be a digital camera that is used to snap picture. So all of that makes it input. And then there is a processing, right? The CPU processes data instruction. So it has a processor in there. Then there is what we call the output device, and this monitor or printer. But let me expand that. If you can also hear it in the case of sound, so a speaker is also an output device. And then we have what is called storage. Now, storage may be permanent or temporary. Temporary, we talk about RAM, random access memory, which I'll cover later on. And permanently, I don't like the word permanently, to be honest. I like the word stored for long term, because permanently would indicate that it is going to exist even through eternity. And that's not. and data can be lost, can become corrupted. So I'd rather say that it can store data for long-term or for future use. So let's delve a little bit more into the central processing unit. I have mentioned a lot of this already, but I am going to go through them just to make sure that you can take note if you need to take note. Other than that, we'll keep going. So as I mentioned, one of the core function of the CPU is the feature of the CPU or part of the CPU is a control unit. And this one is responsible for directing the flow of data and instruction inside the computer. In simple terms, fetch, decode, execute. That's what it does. And then there's the arithmetic logic unit, which we spoke about, responsible for performing calculations and logical operations. All right. And if you have never seen what a CPU look like, this is how a CPU looks like in reality. All right. And of course, this is an abstract view, which we already showed you of the CPUs. Because we can't see these parts, we use this as a way of showing you the parts of the CPU. So in this thing is a control unit, has an arithmetic logic unit. Outside of it, it has a memory of the CPU itself. So let's talk about main memory. Main memory is also called immediate access memory or primary memory, primary storage. Any of those words is speaking about main primary memory. Now, RAM, which we is a shortened form of it, is temporary storage. Look at this. It holds data and it's also volatile. Let's expand on that. Right now, you have Zoom open, whether that's on your phone or whether that is on your laptop. The reason why it's on the screen is because of RAM. If you never had RAM, it would just close, right? RAM is the thing that is needed to hold the data or the program that is currently in use. Now, the thing you need that to store data when it is not in use is called secondary storage. So two things to remember, RAM is used to hold data and programs that are currently in use. So at the moment, any app that you have open on your phone or on your laptop is what we call being stored in RAM. Now, the other type of primary memory that we need to speak about is ROM. Now, this one is permanent storage. Again, it stores instructions. It contains essential instructions for a startup, which means that only the manufacturer can add these instructions. So when the computer is designed, there are some special coded instructions called bootstrap or startup instructions that are stored on the RAM, which every time you press the power button, this begins to load. And that's how you see your computer loading up, booting up. It means that the program is running. It means the CPU is reading how to turn on again. Without this, the computer would not remember how to turn on. This is why you need this, because this tells the computer how to turn on. It remember how to turn on. Without this, your computer would not turn on ever again. You could not store startup instructions on RAM, because if you did, whenever the computer lose power or turn off, the computer would not remember how to turn on. So you have to store it in RAM. Hence, this is called read-only memory, which means you can only read it. You can look at instruction. The computer can view the instruction. You, the user, however, cannot amend, cannot change, cannot do anything to the instructions. All right? Very good. All right. So I want you to write in the chat for me. Write in the chat. What do you think is the major difference between ROM and RAM? What is the major difference? In your own words, tell me, what do you think is the difference between ROM and RAM? And I also want you to expand on that and tell me why is it that we didn't put the startup instruction on RAM, RAM? Why did we not put the startup instruction on RAM instead of ROM? And I'm going back to Colton's statement earlier. A TV can only be used to display images, videos, and live shows, which means it is limited. So that's embedded system. Thank you. Fantastic students. You are doing absolutely well. Today says a television because it is able to read requests from the entertainment that the user would want. So yeah, you can use the remote and you change the channel and the compute and the computer inside, the processor inside you want to go and along. And then this is that on this from inside okay. I All right, good. I'm seeing some response. Thank you guys for your patience. And we are almost landing there because we don't want to keep breaking for too long. So let's see how we get through. All right. So let's hear what Ashani says. ROM is a program placed by the developer in the computer. All right. So what is now? ROM isn't the program. ROM is what stores the program intended to start up the computer. And that special program is called startup instruction or bootstrap. All right. So ROM is an actual device. It is, let me go back on the picture. It's this thing. When you're looking at the computer, you will see something like this on the motherboard. All right. And this is where the program instruction is stored. All right. So watch. And RAM is temporary storage, which was opened by the user. All right. So we have to fix this a bit. RAM actually stores any program that is currently in use. Right now, you're using Microsoft uh, Zoom Oh dear. This is not good. All right. Guys, I'm apologizing profusely. I'm sorry. All right. Okay, let's read some more comments and then let's see if we can run. All right. No, let's look at Colton. Rum is information created by the manufacturer. Again, Colton, rum isn't the information. Rum stores the startup instruction. All right. That's the code that tells the computer how to turn on. Remember, the computer to carry out any form of instruction or any form of task needs instruction to do it. So to turn on, the computer need instruction. The computer is this dumb device that if you don't tell it what to do, how to do, that is called coding. That is called instructions. If you don't tell it how to do it, the computer will never do it. All right. So they load these instructions so that the computer will learn how to turn on. All right. So please make sure that we are making these corrections to our information. RAM actually store the program that we're using and the data we are using temporarily. Please remember that RAM is stored. I like this word today. RAM is versatile. And by versatile, uh, it means temporary store for data. Hold on. Yes. And persistent means, yeah, yes, persistent means that it runs it for long term. All right. Not it's I think the word is volatile, not versatile. Volatile. So volatile. Watch those words. RAM is non-volatile in the sense that when you turn off the computer, it still holds the instructions or programs that are on there. All right. I'm going to give you homework, because we need to get these things right. Let's carry water, but ram. Let me know, guys, if my instruction is clear and you're good. Just type good in the chat. In the meantime, now remember now, we don't only need to store startup instructions. So we need something more than ROM. And we don't want to store our programs, our data only when the computer is on temporarily, because that would be catastrophic. That is terrible. Think about a situation where if all your work that you type up could not be stored for long term, what would happen to you? It would mean every time you turn the computer on, you have to turn, you have to do it all over again. So you need something called secondary storage. Secondary is used for long-term, short storage of data and programs. So the the reason why when you close Zoom today and come back next class and try to open Zoom, the app is still on your phone is because of secondary storage. Um, all right. Oh, I am Okay, I wanted you to type good in the chat if you're now clear as to what RAM are. Okay, you understand the difference between ROM and RAM. If you think you're clear, type good or go again. All right, and we will go again. So in the meantime, secondary storage is needed for long term. So I want to be able to save my SA for long term. I want to store my SBA for long term. I want to store my letter for long term. I want to store the program I download to play my game for long term. And that is why we all need secondary storage. Nice, Katrina. Thank you very much, Jide. All right, now go on. So here are some examples of long-term memory. Meaning you can store for long. CD, DVD. People don't really use this again, but it is still on your syllabus. So you need to know it. CD, compact disc, DVD, digital versatile disc. Some people say digital video disc. They had a long debate about it, but we came to the conclusion that is digital versatile disc. Then we have what is called hard disk. Then there is what is called floppy drive or floppy disk. We have what is called flash memory. You call this USB, some people call it pen drive, and there are people who call this one tape drive. Now I'm going to give you a little bit a deep analysis on one of these. When we talk about, for example, storage, you see all of this thing right here is considered the hard disk. But there is two things that we have to distinguish. There is a distinction between the drive and the media. The drive plus the media makes the overall storage device. I'm going to say that again. Let's take, for example, hard disk drive. This here constitutes of both the media and also the drive. The drive is the mechanism that is in place to write to the media or to read from the media. In the case of a hard disk, it is called a read and write head, which simply goes along the platter and read what is on there or write to it when you decide to store. So when you're opening a file, the read and write head goes and check what you want to open and open it for you. And of course, when you need to save something, it also goes and write to it as well. All right, just to let you know. So let's break that down again. When we say hard disk drive, it is a combination of the media plus the drive. The drive does the reading and the writing, and the media is the actual material on which you are storing. Altogether, they form the hard disk drive. Let's talk about CD because it is also applicable to CD. The actual little CD that you see, that little round something, is called the media. The CD plus a CD drive, that's why I mean the drive plus the media makes the CD drive. All of this is the compact disc drive. Same thing for the DVD. This little circle part here is called the DVD. The DVD shell with everything that reads the instruction with the laser inside of it is called the DVD drive. All right. So when we talk about secondary storage media, the very same thing is applicable to all of the other devices. Floppy disk drive, same thing. The drive does the reading. The floppy disk is the actual media. Okay, so when we talk about secondary storage and you hear compact disk drive or hard disk drive, it is talking about all of what allows for the storing of data. Versus when we say the media, we are talking about the actual thing on which the data is stored. If you understand that, please type it. Good. Right. Good. Good. If you got me, you understand me, you are clear as day on what I just explained, please to type good. All right. Thank you very much. Nice. All right. Good, good. We're doing all right. So let's now move away from storage device, which we will speak more about as we continue to study this very interesting unit that you have. We're now going to be talking about input and output devices briefly because today we just want to understand why it is general purpose computer, what are the functions, what are the devices. So input output, as the name suggests, input devices are used to put data, instruction, or signal into the computer. And some examples of those are keyboard, mouse, scanner, microphone. Output device opposite is used to display output, whether that is in the case of sound, like speakers, or produce hard copy, like in the case of printer. By hard copy, we mean an actual paper with actual writing that is tangible. You can hold it, you can touch it, you can feel it, you can dash it down, right? And then in the case of soft copy and projector, like now you're seeing the screen on my computer, that is called soft copy. You can see it, but you cannot touch it. You cannot take it up, you can't hit it down, all right? Because it is soft. Now, I like to use my my illustrate that there are some devices that can be both and output all at once. And some of those include, and we see them around, all right, like a webcam and all those. All right, but we'll talk more about those as we venture on. Let's now look at primary storage device. We spoke about these earlier already. I'm just repeating for making sure that we do need to understand it is ROM and RAM. This one over here stores the this one here, Colton, this over here is an actual device. This is something you can actually touch. This is and the instructions and data that are currently in use. So if you type a letter, before you hit save, it is temporarily stored here. That's why you can see it on the screen. All right. Now, the startup instruction that you need, that the computer needs in order to turn the computer on is stored on this one. And this one is called the ROM. All right. Let's run along. All right. So we just mentioned them already. So we all of this is just repetition sake. So let's run along from this. I did mention earlier, and so here where I'm going to show you where the vision of designing the modern day CPU comes from. So this is just a design. You know, like when somebody design a trousers or a pants, and then 10 other people take the same design and build something. So this guy named Van Neumann in the 1940s decided that he needed to design a brain for the computer that would determine how the computer would actually function. So he came up with this design. And ultimately, the CPU that you see, all right, is made following this design. So I just wanted to point that out. And this is why on his design, he had a single control unit, which we explained before. On his design, he also had an arithmetic logic unit. On his design, he had a single memory that also holds data and program. Now, I don't need to go into these registers, but they are very integral to the functioning of the CPU. But at your level, at CXC, you don't need to know all of this. All right. But I wanted you to understand where the design came from. His name is Von Neumann. In fact, John von Neumann. Here's his name up here, Von Neumann. And his first name is John. He was an Hungarian and he was a specialist in mathematics and physics. All right. And so he's the one that designed or came up with the design for the modern CPU that we now use. When he designed it, he wanted the input device to be able to interact with the processor and the output device to also be able to interact. So this is how the user will either use a keyboard or a mouse to interact with the computer. The CPU is going to do the processing and display it in the output, whether that's a speaker or that's a monitor. All right, that's an abstract. The thing I just showed you that is called RAM, that is what is called memory here. And this is what stores the data and the program that is currently in use. So everything that we explain can be summed up nicely using this diagram. The RAM stores the data and program currently in use. In order for the CPU to process anything, it must be a resident of the memory. It must first be in the memory. If it's not in the memory, it cannot be processed. All right, it needs to be in the memory in order to be processed. So even if you stored something for long term on your secondary device, it has to, when you turn your computer and load up the device, what it is actually doing in reality is moving that file or moving a copy of that file at least from where it is stored in secondary memory into main memory. When you're done processing, meaning you're done type and do the addition stuff that you want, that is why you now have to click on file and save. By file and save, what you're doing is to move the file from out of main memory into secondary storage. When you close the file, what you're saying, it is no longer occupying main memory. So this is a nice way for you to sum up the general purpose computer and how it functions. There must be input devices which allows the user to get data into the computer. There must be output device that allows the user to either see or hear what is being typed or what has been processed. Yes. And of course, there is a memory that is currently storing the data and program that is being run. And of course, a processor that does the processing. If that is good, would you go ahead and type good in the chat? Fabulous. Thank you, Ashanti. Where are my other students? Is it good for you? If it's not good, tell me, because this teacher will teach it until you get it, right? That's what I do. All right, nice. Jude said, nice. All right, Colton said, good. What about my other students? Come on, get to the keys. Process something for me, type something with your input device so the CPU can process it and display it on my screen so I can see it. Where is Katrina? Where's Adam? Those keys typing. Come on, my students. Give us some response. All right. Nice. I see one more come. All right. Yes, Katrina, you just use your keyboard, your input device, and send something to the brain, and the brain show it on my screen. I see you're good. All right. Yes, we're doing well. All right. So I now wanted to talk about PROM. All right. Now, PROM stands for Programmable Read-Only Memory. I want you to know that this is a type of ROM. So that's why it is read-only memory. So let's look at PROM and why we need PROM. So PROM is also a type of non-volatile. What does non-volatile mean? Again, somebody type it in the chat. Someone type it in the chat. Tell us what non-volatile memory is. Please, I am begging you to type it in the chat. PROM is a type of non-volatile memory that can be programmed once after it is manufactured. Somebody tell us what non-volatile mean. non volatile. Volatile. Come on, guys. Don't let the internet non volatile. Nice. Nobody could write, only the manufacturer. So it came programmed, but with prompt, you can actually write it one time, just only one time. All right. So that almost there, almost there. Thank you for your patience. Thank you for not giving up on me. I am looking for your comments just in case you have time. But let me just quickly go ahead and talk. So remember that rum, so prom is a type of rum. Well, let's look at what the difference was. Remember that rum, you you could not write to it at all as the user. Only the manufacturer could write. That's why it was read only memory. But with prompt, it can be programmed once, which means if you get it from the manufacturer, it can be programmed once after it is manufactured. All right. And again, it stores permanent data or instruction that cannot be altered after programming. So this one is called programmable because it can be programmed once after it is manufactured, and it cannot be changed after. That is a major difference with for. It is used to store or to retain, yes, retain firmware or software that does not require update. So any program that does not require an update, don't require any form of change or modification in the future, a good thing to store it on is a PROM. All right? PROM. So firmware software. By firmware, we mean programs embedded in devices like calculators, printers. So remember we that talk about the washing machine and the microwave that cannot be changed. We just have one function. Yes, that's an example a firmware is embedded devices like calculator, printer, household appliances, and they cannot be changed. It can also be used to store microcontroller programming, which means to store control programs in microcontrollers. Startup instruction for computers are embedded systems. And it is also used for custom logic storage, which means to store fixed tables or lookup data in. Remember, it can only be programmed once after manufacturing and then cannot be changed again. That's a major difference. With read-only memory, it comes programmed already and cannot be programmed once manufactured and then it cannot be changed again. You must know at least one example of what uses PROM. And I said to you, we plans earlier, and that cannot be altered. Yet we can. All right. Finally, guys, finally. All right, we're going to talk about EEPROM, and then we are going to pause for this up next week. So EEPROM stands for Erasable Programmable Read Memory. So with ROM, you get it from the manufacturer programmed and it cannot be changed. With PROM, you get it from the manufacturer and it can be programmed once and then cannot be changed. Then we have EEPROM, which is erroneous programmable read-only memory. And this is a type of non-volatile memory. Again, non-volatile means that it retains the data for long term. That cannot be erased. That can be erased and reprogrammed multiple times. I love this. So the major difference with EEPROM is that it can be erased and programmed multiple times. All right, that is the main difference. Now again, we look at where it is used. It is used in some embedded systems, right, to store programs that may require periodic updates or fixtures. So there are some embedded systems in the modern context, even though we mentioned that they are hardwired, most of them are hardwired, but there are some new updated modern ones that are coming out that might need regular updates, but still it doesn't change it from being a embedded system because the function is still limited. So even though it might be able to get a little update because they decide to use EEPROM and not PROM and not PROM, they have used EEPROM, you cannot upgrade its functionality. It still remains. So this is why it is still embedded system. All right. So that is the major difference. So if I could just put a little table up here to summarize what I've spoken about. PROM, the difference between PROM and EPROM. So PROM can be programmed once. EPROM can be programmed multiple times because you can erase and keep adding programs. It cannot be erased, whereas EPROM can be, and it uses something called a UV light, ultraviolet light. In terms of volatility, both of them are non-volatile, which means they retain the data after the computer or the embedded system is turned off. For PROM, it is used for permanent firmware, things like calculator that will always be a calculator, cannot be updated. Whereas EPROM is used for more advanced type dating, maybe like in development testing. All right. So these are more advanced. Cool. In terms of cost, PROM is way lower. It is usually lower, whereas EPROM is more. And we can come up with a reason for why. Because one of them can be used multiple times, whereas one cannot be. All right. So that is going to be my presentation. I want my classes to be about one terms of an activity. If you're in the class, you have signed up for the Google class, there is an activity in there that I would love for you to complete for me, which will help me to understand what you have understood from today's lesson. All right. So if you could do me that huge favor and jump into that class, I noticed that there's only 2 people joining my class, and I don't love that. So let me send you the link in the chat, and I'm going to ask you to use the rest of this class time to work on this. All right. I suspect Colton was saying the information is stored for long term. Nice. Very good, Colton. I think you're responding to what volatile means. So well done there. Really, really appreciate that. So there's a class link if you haven't joined it yet. And I ask you to complete that little document. It is just for me to gauge what you have grasped from today. I'll take some time and read through that. And yeah, we'll be back here next week. So you have just about, I want to use a class time. So you have about 46 minutes to work on that simple activity for me. You can work on that on your own and then just send it to me and I will check it right after. All right. Because my internet keep going in and out, I'm going to relieve you of the burden of having to keep connecting or waiting on me as I get cut out. But please make sure that you join the class before you leave. So if you have joined the class, just type join in the chat before we break this part and allow you to go do some independent work. So I can see Felix. Join. Nice. Katrina is there. Today is there. What about the rest? Are we there already? Just type join if you're already in.
Sir, everyone is on the same document. As in, everyone can type on the same document.
Yeah, the same document. Can you download a cut? Or you're asking if you can do it together or just one person?
No, as in when I go on it, everyone is on it. Like when I go on it, everyone is on the same thing.
Okay. You know, in order for me to fix, I'm gonna fix that after. Can you just download a copy? Sorry about that.
Yes.
Just download a copy, and I'll send you an email, and you'll just email that to that to my email, and I will figure out what is going on, and then fix that for the next activity. Thank you for pointing that out. I'm gonna send you my email to do this. All right, so that's my email. So once you're finished, just email me the completed form. I'll work on fixing that thing in the background so that you don't have to go through all of this pressure. All right. Did anybody have any question for me before we break today? Any question? Any question? None? All right. If there are no other questions for me, again, I'll give you the rest of the time to work on that activity for me and send me as soon as you're done. All right, so don't go to bed. Don't wait until tomorrow. Finish it and send it to me. With that said, I thank you for being here. And of course, we'll meet again next week. Same place, same time. And I'll hope that all is sorted out. We have a storm again where I'm at, and that is why my internet keep going. Hopefully, next week, that will all be resolved in my location. With that said, I want to wish for you a productive afternoon. Do enjoy your weekend and have a good day, a good week in school.